Right, section 4 in this chapter has to do with areas of all the different quadrilaterals. So I'm going to break it down and we'll go through each of the individual kind of subcategories of these, and then I'm going to give you some time to work. The first of them is a parallelogram. Okay? So if you took a parallelogram, so all you knew is that the opposite sides were parallel to each other, and you wanted to figure out the area of this. Okay. If you were to draw in one diagonal in a parallelogram, you create two triangles. Now, what do you know about those two triangles? Bless you. Josh.
They equal 180.
Okay, so the angles are equal to 180, but what about the two if you compared these two triangles to each other? Okay. They're congruent, right? They're equal in all respects. And the reason you know that is in a parallelogram, opposite sides are equal. So we have these two pairs of sides are equal, and then the shared side equal. So by SSS, we know that these are two congruent triangles. So if I wanted to derive the area formula for a parallelogram, since we've already discussed the area of a triangle, really what we're doing is taking two times one of these triangles, since they are congruent, which means 2 times the area formula base times height. Well, 2 and the 1/2 cancel here, leaving just your area formula base times height. So for any parallelogram, the area formula is base, so here's my base, times the corresponding height. The height is just the perpendicular distance between the two bases. Okay, now, there's nothing that says, just like with the triangle, there's nothing that says you can't use this as your base. So if I call this base 2, then its corresponding height would be the perpendicular distance, h2. It would still be the product of the base times the corresponding height. Okay. So let's take a look at the type of problem that you might see involving parallelograms. Again, it's not just going to be, hey, here's the base, here's the height, what's the area? Okay. It'll be more similar to something like this. Right, given a parallelogram with sides of 8 and 10 and one angle of 60 degrees, find the area. Okay, I want you just to take a minute or two, see how far you can get on this type of problem before I talk through it. But again, I'll start talking through it in about a minute or two. All right, you should be pretty close to being able to get an answer. And let me talk through, again, kind of how you could go about setting this up. All right, anytime you're beginning with a problem, start with the formula. So we have area of a parallelogram. So base times height is the formula for that. Do we know either of these values? Let's say the base is 10. So all we need to do is find what the corresponding height is. Oftentimes, it's easiest to draw in your height from a vertex because that creates a right triangle that you can use as a reference. So here is the height that we're looking for in this figure. Okay, by drawing in this height, we created a right triangle with a 60-degree angle, this 90-degree angle. Therefore, we have a 30, 60, 90. If the hypotenuse is 8, what does that mean this side opposite 30 degrees is going to be? Again, we have an x, 2x, x root 3 pattern, so it's going to be a 4, half of 8. And therefore, if the side opposite 30 degrees is 4, the side opposite 60 will be 4 times root 3. So that gives us our height, and we can simply multiply 10 times 4, 40, root 3. It's an area, so we're measuring in terms of square units. So 40 root 3 becomes our area. And now, what I wanted to demonstrate on this is it doesn't matter which base and height you choose. Let's say you had this other alternative, which was to choose this base of 8. So if you chose your base as being 8, your corresponding height is going to be the perpendicular distance from base to base. Well, this length is still 10. Opposite sides of a parallelogram are equal. Opposite angles of a parallelogram also equal. So we created this 30, 60, 90 right triangle here to find H2, this second height. And so using this 30, 60, 90, if the hypotenuse is 10, that means the side opposite 30 degrees is half of it, or 5. And then the side opposite 60 degrees will be that length 5 times root 3. So 5 root 3 becomes our corresponding height. Well, 8 times 5 still gives you 40 times the root 3. Again, square unit. So it doesn't matter which pair of base and height you use. It's going to give you the same area regardless. Okay, so again, it's a lot like triangles in that sense that with triangles you have 3 different pairs of base and heights. With parallelograms you have 2 different pairs.